Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of factor theorem. So as per the problem, factor the polynomial and we are given this cubic polynomial 3x cubed plus x squared minus 22x minus 24. This polynomial has 4 terms. We cannot factor this polynomial using the grouping method, so we have to use rational roots theorem. The leading coefficient of this polynomial is 3. It is not equal to 1, and the number term in this polynomial is negative 24. The first step is to find the factors of the leading coefficient and then the number term. The factors of 3 are plus minus 1, plus minus 3. The factors of negative 24 are plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 8, plus minus 12, and plus minus 24. Next, we have to find the possible x values that will make the value of this polynomial equal to 0 by dividing each factor of the number term by the factors of the leading coefficient one by one. So let's start by dividing the factors of 24 by plus minus 1. 1 over 1 is equal to 1. 2 over 1 is 2. 3 over 1 is 3. 4 over 1 is 4. 6 over 1 is 6. 8 over 1 is 8. 12 over 1 is 12. 24 over 1 is 24. Next, we have to divide the factors of 24 by 3. So we start with 1 divided by 3, then 2 divided by 3. 3 divided by 3 is equal to 1. We already have 1 as one of the possible x values. We can move on to 4 divided by 3. The next one is 6 divided by 3, which is equal to 2. We already have that in our list. The next one is 8 over 3. The next one is 12 over 3, which is equal to 4. We already have that in our list. And the last one is 24 over 3, which is equal to 8. And we also have that in our list. So these are the possible x values that will make the value of this polynomial equal to 0. Now we have to find which are those x values. Let's assume the given polynomial can be represented by function f at x. Now we have to sub in the x values one by one from our list. So let's start with x equals 1. This expression value is not equal to 0. So x equals 1 does not work for us. Let's try the next x value, negative 1. The value of this expression is also not equal to 0. That means x equals negative 1 doesn't work for us. Next, we can try x equals 2. If we evaluate this expression, we do not get 0. That means x equal 2 doesn't work. Next we can try x equals negative 2. Negative 2 to the power 3 is equal to negative 8, and 3 times negative 8 is negative 24. Negative 2 squared is equal to positive 4. Negative 22 times negative 2 is equal to positive 44. The value of this expression is equal to 0. That means for x equals negative 2, the value of the polynomial is equal to 0. We can find the binomial factor by setting the equation equal to 0. So we should add 2 to both sides. So the binomial factor is x plus 2. Next, we have to divide the polynomial by this factor to find the quotient for this polynomial division. We can use long division or synthetic division. For this problem, we'll use synthetic division. The first step is to list the coefficients of the terms in the given polynomial, and the number term, we start with the leading coefficient. Next, we write the x value from the factor on the left side. Now we can start the synthetic division. The first step is to bring down the first coefficient. Next we do negative 2 times 3, which is equal to negative 6. 1 plus negative 6 is equal to negative 5. Negative 2 times negative 5 is equal to positive 10. Negative 22 plus 10 is equal to negative 12. Negative 2 times negative 12 is equal to positive 24. Negative 24 plus 24 is equal to 0. 0 is the remainder of this polynomial division. That proves that x plus 2 is a factor of the given polynomial. The degree of the polynomial is 3. The degree of the factor x plus 2 is 1. That means the degree of the quotient should be 3 minus 1, which is equal to 2. So we can assign x squared to the first number 3, x to the second number negative 5, and negative 12 is the number term in the quotient. Now we can write the factored form of the polynomial. We start with the first factor, and now we can write the quotient. Next we have to factor this quotient expression. This is a complex trinomial. We can use decomposition method or crisscross method to factor this complex trinomial. I will use the decomposition method. The first step is to find two numbers whose sum is negative 5, the coefficient of the x term, and product of the numbers should be 3 times negative 12, which is equal to negative 36. To find the two numbers, we should analyze the product number. So the first pair of number that comes to my mind that multiply to negative 36 is negative 1 and 36. But we cannot get a sum of negative 5. So this pair is out. The next pair that comes to my mind is negative 2 and 18. but we cannot get a sum of -5 from this pair, so this pair is also out. The next pair can be -3 and 12, but we cannot get a sum of -5, so this pair is also out. The next pair can be -4 and 9. -4 plus 9 is equal to +5, but we are looking for -5. That means we have to switch the signs on these numbers. So the numbers are +4 and -9. So these are the two numbers we are looking for. Now we can use these two numbers to break up the middle term. Now we can use the grouping method. We'll pair up the first two terms and the last two terms. We have to do common factoring from each pair. From the first pair, we can factor out 3x, and from the second pair, we can factor out a 4, we can factor out x minus 3 from both terms, and we are left with 3x plus 4. So this is the fully factored form of the given polynomial. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.